Welcome, my dear students. I hope all of you are fine and doing well. So, the topic here that we are going to discuss today it is the covalent radii and the ionic radii of transition elements. So, transition elements are basically the elements that are called as D and F block elements. Why they are called as F and D block elements? Because they have their valence electrons in the F subshell and D subshells. Now, here we will discuss about their covalent and ionic radii. Before this, you guys must know that what does mean by covalent ionic radii. Basically, the covalent radii, it is the covalent radius, which is basically the half of the distance between the two atoms that share a covalent bond. If we have any compound or any molecule that is made up by the help of the covalent bond, now the distance between the nuclei of the two atoms, it is known as the covalent bond length. And half of this distance is basically known as the covalent radius. The distance between the bonding electrons towards the nucleus of this substance or atom, it is called as the covalent radius. On the other hand, when we talk about the radii, which is called as ionic radii, if we have an ionic compound in which the one is cation that contain the positive charge and the other is anion that contain the negative charge. Now the distance between the nuclei of these two ions, and when we take their half, then the nucleus distance from the bonding spot, it is the ionic radius of the cation. On the other hand, the anionic distance from the nuclei to the bonding, it is known as the ionic radius of the anion. So the distance between the two nuclei and then the half of this between nuclei of the ion and the bonding spot, it is called as the ionic radii. Now, what will be the ionic radius of the transition metals? Let's have a look on it. Basically, when we talk about the covalent radius of the transition elements, first of all, we just looked at there is the gradual decrease in the covalent radii of the first series, which is called as the third series, and then they almost we can say that becomes constant after some time, and final after there is a simple increase in their covalent radii. Likewise, if we talk about the 4D series, then there is an increase in the radii possibly just because of one reason, because they have filled 3D orbital. There is a gradual decrease and then there is a simple increase. This is just due to the filled 3D orbitals of transition elements. Likewise, if we just have a look on the series of the 4D and 5D, in this, with the increase in the atomic number, as here along x-axis, there is an increase in atomic number. We just see that if the first element, likewise, if its oxidation number or atomic radius is 10, here we have 20, 30, and 40. With the increase in the atomic number, we just see that if its atomic radius is at 17.5, then the next is having lower than the 17 and then lower than 16.5 and so on. So there is a decrease in the covalent radii and after some time it becomes constant. Now why it becomes constant or why it is going to be increased? The simple reason or answer is that there is an involvement of 3d orbital electrons, and first they have partially filled orbitals and then they move towards the filled d orbital electrons. So that's why their covalent radii is going to be decreased with the increase in their atomic number. After this, we have the ionic radii. There are also some changes in the ionic radii along the series that is not really regular. So there is a basically periodic trend in the properties of these ions. For example, here we talk about the scandium when its oxidation state is plus 3. Here it's a covalent radii or ionic radii is high, but when there is the next titanium, it is in oxidation plus 3, its ionic radii will be less as compared to the scandium. And then when we move from titanium to vanadium, as V positive 3, it also decreases. And when we move from vanadium to chromium, here it is in oxidation number plus 3, its ionic radius also decreases. And when we move towards the manganese, which is Mn3 positive, there is also decrease in its simple ionic radii, and then there is gradual increase. But when we move from cobalt to nickel, its oxidation state is plus 3, there is an increase. So why there is an increase? Because there is the involvement of 3D subshell electrons, and they are moving from partially filled d orbitals to towards the filled or completely filled d orbitals. This is the simple reason for its decrease, and then there is an increase in their ionic radii. And here the unit that we use for its representation, it is picometer. So this was the simple topic that we have today. I hope you guys understand. And if you have any queries, you may ask me about that in the comment section, and I will get back to you guys soon. So the next topic that we will discuss, it is the paramagnetic behavior of the substances. For that time, you guys keep learning and have a good day.